All right, in this video, I am going to prove this trig identity over here. Now, the quickest way to do this question is to use co-function identities. But because most schools do not teach co-function identities, I'm going to solve this using a slightly longer method, basically by using my compound angle formulas. Now, the first thing I'm going to do in this question is I'm going to convert just this tan and this cot into sine and cos. And the reason why I'm only converting these two over here is because if you have pi over 2 and 3 pi over 2, you need to use sine and cos because you cannot do tan of pi over 2 and tan of 3 pi over 2 because those are vertical asymptotes and you cannot solve it that way. Over here, I have 2 pi and pi, so I can just use my compound angle formulas for tan to solve those two. So let's start by just converting this to sine over cos, and this one to cos over sine. I'll leave these two the same. And then I just want to do my compound angle formulas for all of these, which is quite a bit. So it's not going to fit in one line, so I'm going to span it across two lines. Let's start with that one first. Go on to the second one there. And let's go to the third one. I'll do that on the next line. And this one here is just the tan formula upside down. So tan pi minus, oops, I have a tiny mistake here. This is a plus. Tan x 1 plus tan pi tan x. Next, we are going to just calculate all of the exact values. I know sine pi over 2 is just 1, cos pi over 2 is 0, cos 3 pi over 2 is 0, sine 3 pi over 2 is negative 1, 0, 1, negative 1, 0. Tan 2 pi is 0. Tan pi is also 0. And I'll just write this step a bit more neat on the next line over here. 1 times cos is just cos x. 0 times sine is just 0. To the bottom next. Now 0 times cos is 0. 1 times sine is sine. Go to the next one. 0 times cos is 0. Negative 1 times sine is negative sine x. And then negative 1 times cos is negative cos. And 0 times sine is 0. Go here. I just have 0 minus tan x. And then 1 plus 0 times tan is 0. Then let's do the last one over here. 1 plus 0 times tan is 0. And on the bottom, I have 0 minus tan x. So now let's simplify all of these fractions. Let's get rid of all the zeros. So here I just have cos x over sine x. Here I have negative sine x over negative cos x. Over here I have just negative tan x over 1, and the last one is just 1 over negative tan x. Next, I'm just going to get rid of all my negatives and turn everything into tans for now. So cos over sine is just 1 over tan x, basically cot x, minus sine over cos is just tan x. And the reason I'm turning everything to tan is because on the other side I have a tan in the denominator. So I'm kind of going off that. I also know that I can get sec square from tan square using my Pythagorean identities. That negative tan over 1 is just negative tan x, and then these two negatives cancel. I'm just left with 1 over tan x. Next, I'm going to combine like terms. So 1 over tan plus 1 over tan is just 2 over tan. They already have a common denominator. Negative tan minus tan is just negative 2 tan x. I know on the other side I have a common denominator of tan x. So I'm going to make a common denominator over here. This just becomes tan square x. So now the denominators are the same. I just have to manipulate the numerator. I know that tan square is just sec square minus 1. We'll continue over there. That's my Pythagorean identity. I'll multiply this negative 2 into the bracket. And last step, I will combine like terms. So 2 plus 2 is just 4. And now this matches the other side of the identity. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.